How _future_ imports work under the hood. I've been fascinated by the _future_ module, in particular, its ability to change the way statements are parsed in Python. What's most interesting is how doing something like enables you to use print, and not print _function, like you would expect any other normal import to do. I have read what is _future_ in Python used for and how/when to use it, and how it works thoroughly, and in particular came across a particular line. A future statement is a directive to the compiler that a particular module should be compiled using syntax or semantics that will be available in a specified future release of Python. I would love to know the intricacies of what exactly makes this possible. In particular, how something like can enable true division on Python 2, while can enable the syntax on Python 3. What I find most funny is that you have to import a feature from _future_ for backward compatibility. Anyway, to summarize, I would like to know how the directive is understood and executed by the compiler when _future_ or its artifacts are imported.
From _future_ import print _function tells the parser to not treat print as a keyword, leaving it as a name instead. That way the compiler treats it as a function and not a statement. To track this, the compiler struct has a c_future field that holds a pyFutureFeatures object that tracks which future directives have been enabled. Various parts of the parser and compiler check the flags and alter behavior. This is mostly handled in the future.c source file, which has a future_parse function that checks for import from AS objects with the module parameter set to _future_, and sets flags based on what is found. For example, for the berry _is_fluffle feature, the parser refuses not equal as syntax but accepts, instead. You can find the other examples by graphing for the future_flags listed in compile.h. Note that there is a _future_ Python module, but it is not directly involved in the parsing and compilation of code. It is merely there to give Python code easy access to metadata about directives, including bitfield values to pass to the flags argument of the compile function, nothing more.
Quirky.